Alright guys, this is the video solution to tutorial sheet 11. There are 7 questions. As usual, I will go through every single one of them and give you detailed solution. This is on top of the typed solution for sheet 11, which you can find on the course website. So let's start with question 1. So here we are trying to test this versus this and this versus this, where mu is the mean breaking strength. It has a standard deviation of 30, and we want to test using alpha. Alpha is the level of significance equal to 0.05 and 0.01. N is the sample size. The sample size is 40, and the sum of the data is this 8328.4. So let's see how we can do this. Okay. So this is question 1, part 1. All right. Now, before I start, you should look at the video on one sample tests. You will see that I've given you the rejection rules for this kind of hypothesis, and when the population standard deviation or the population variance is known, which is the case in this example, the rule for rejecting the null hypothesis in favor of the alternative is the following. Right here, x bar is the sample mean, mu0 is the value specified by the hypothesis, sigma is the population standard deviation, n is the sample size, and this is the percentile of the normal distribution. Right. So this is you should be able to remember this from. You should have looked at the video on the one sample tests. You should know this, right? Okay. So that's what I'm going to use to do part 1, right? So we are told that mu0 is 200. We are told that n is 40, and sigma is 30. X bar is the sample mean, which is we are given the value for the sum of xi, which is this, right? So it's going to be 1 over 40 times the sum of xi, which is 8328.4. Okay, and you should work this out. It will be 208.21. All right. And alpha, we're going to use 2 different alpha values. We're going to take alpha to be 0.05 or 0.01. Right. So okay. Before doing that, let's compute this guy here. X bar minus mu0 divided by sigma by root of n. Alright, so this is going to be 208.21 minus 200 divided by 40. Root of n is, sigma is 30, sorry guys. Sigma is 30 divided by root of 40. Okay. Now you should work this out. this will be equal to 1.731. Okay, so that's the value of the statistic, 1.731. Now, if alpha is 0.05, if alpha is 0.05, then the percentile value, which is this one, this is Z 0.975, is going to be equal to 1.96, right? And clearly 1.731 is not greater than 1.96. So there is no evidence against. So the conclusion that you can make here is that there is no evidence against the null hypothesis. So we cannot reject the null hypothesis if alpha is 0.05. Now let's try alpha is 0.01. So if alpha is 0.01, right, then this guy will be set 0.995, right, which if you work it out, it will be 2.576. So still 1.731 is not greater than 2.576. So still there is no evidence against the null hypothesis. Alright, so this completes the first part of question 1. The second part is to test this hypothesis versus this hypothesis. Alright, so let's see how we can do that. So this is question 1, part 2. So we are trying to test mu equal to mu 0 versus the alternative that mu is greater than mu 0. Now, once again, you should look at the video on one sample. You should look at the video on one sample tests, right? The procedure for rejecting the null hypothesis is if this is the procedure for rejecting the null hypothesis. Right? So you should be able to see this from the video or the notes or the printed notes. Okay, now let's try to work this out first. Right? X bar minus mu 0 divided by sigma by root of n. We know what X bar is. X bar is X bar we have worked out before is 208.21. Mu 0 is 200 divided by sigma is 30 and n is 40. Now, if you work this out, this will be 1.731. Alright? Now, you want to compare this value with this value, right? Now, if alpha is 0.05, then right, and this will be equal to 1.645. Okay, so in this case 1.731 is greater than 1.645. So what you can say is that in this case there is evidence against the null hypothesis. Okay, that's when alpha is 0.05. Now if alpha is 0.01, then okay, is equal to this, and this is equal to 2.326, right? Okay, so here 1.731 is not greater than 2.326, right? So here there is no evidence against the null hypothesis, right? So this completes question 1. Alright, now let's move to question 2. So here we have a sample of size 10 from a normal distribution with variance equal to 3, unknown mean. The sample mean is 0.7, and the first part is to test mu equal to mu 0 versus mu greater than mu 0, right? So remember what I said in the previous question. We know the rule for rejecting the null hypothesis in this case, right? So we reject. So let me write it. We reject H0 if x bar, the sample mean, minus mu 0, which is 0, divided by sigma, which is square root of 3, divided by root of n, which is root of 10, right, is greater than z1 minus alpha, which is alpha is 5%, so it's 1 minus 0.05, right? So this is the same as saying that x bar we already know is 0.7 divided by 0.3 in square root is greater than, okay, and this guy becomes equal to 1.278, and this guy we know from earlier question is 1.645, right? So clearly this is not true. It's not. 1.275 is not greater than 1.645. So the conclusion is that there is no there's no evidence against the null hypothesis, right? All right, so that's part 1. Part 2 is to calculate the type 2 error if the true value of mu is 1, also if the true value of mu is 1.5. Right. So we want the probability, we want to compute the probability of type 2 error. Remember that the probability of type 2 error is the probability of accepting the null hypothesis when H1 is true. Okay. Now this is the rule for rejecting the null hypothesis, right? So we will accept the null hypothesis, right? If the x bar, right, divided by root of 0.3, right, is less than or equal to, right? Okay. So this is just the opposite. Here you have greater than, here you have less than or equal to. So let's take the first case. We are asked to find the probability for two different values of mu, right? So let's first consider the case mu equal to 1. Okay. Now, what I'm going to do is the following. I will explain why I'm doing this in a minute. Okay. You see, I have subtracted a 1 and added a 1. Now I'm going to group these two together, and I'm going to take this term here to the right hand side. Right, now I want you to recall a property that I talked about in the video on normal distribution. Now, if you have a sample, let's say x1 to xn, IID from normal distribution with these parameters, then the following statement is true: x bar minus mu divided by sigma by root of n has the standard normal distribution. This is a property I mentioned. Well, okay. Okay, so here I'm going to use this in this step here, because we are told that the true population mean is 1. So what you have here is x bar minus mu divided by root of 0.3, which is sigma by root of n, right? So this, because we are conditioning on this must have a standard normal distribution, right? So using this property, okay. All right, now we don't need the conditioning anymore, because the conditioning has been used to argue that this term here has a standard normal distribution. Therefore, we have used the conditioning. Therefore, we don't need it anymore here. Right? Okay. All right. So what you have here is phi. Remember, phi is the CDF of the standard normal. At this guy is 1.645. 1.645 minus 1 divided by the root of 0.3. And you can read this. You can read this from the table. And for mu equal to 1, this will be 0.43. Okay, 0.43. Now we need to do the same thing, the same procedure that we have done here when mu equal to 1.5. So let's try to repeat this for mu equal to 1.5. Right. So So this is still part 2 of question 2. Okay, so we start with the probability of type 2 error, which is the probability that we accept which is the probability that, so the probability of accepting is the opposite of rejecting, which is this. Okay, now this time we are conditioning on the fact that the true population mean is 1.5. Okay, so what I'm going to do is slightly different from what I did earlier. So I'm going to subtract 1.5 and add 1.5. Okay, now let me put this in a bracket, right? Let me put this in brackets. Now I'm going to take this term here to the right hand side. So this will be right. Now using the same property that I mentioned earlier, right? This guy here must have a standard normal distribution, right? Conditioning on this fact. So what you have here is the probability that right. Okay, so once again we don't need the conditioning anymore because we have used the conditioning to argue that this has a standard normal distribution. Alright, so this is 5 at, this guy is 1.645. Okay, 1.645 minus 1.5 divided by square root of 3.3, and if you read this off the table, you should get 0.14. Right? So that completes part 2 of question 2. Now part 3, let's go back to question 2. Alright, part 3 is assuming that the sample mean remains the same, how large would the sample size need to be in order for H0 to be rejected in favor of H1? Right. Okay, so now you should go back to part 1, which is this one, right? We said that we reject the null hypothesis if this is the case, right? That's with a sample size of 10. Now the question is, what is the sample size that we need, right? So that this here becomes greater than this, right? So that's the question. So to do part 3, we need to find n such that x bar divided by root of 3, right? Root of 3 divided by root of n, okay, is greater than z 0.95, which is 1.645. Okay. So this is so in other words, we need to find n so that this, whatever this is greater than 1.645. So this is the same as saying, right? X bar, we know it is 0.7, so it's 0.7, yes, 0.7 divided by times root of n divided by root of 3 is greater than 1.645. Okay, so this is the same as saying that root of n is greater than okay. Now we should square both sides. Take the square of both sides. It becomes n greater than 3. Okay. Right now, we should compute this, guys. We will get this to be approximately equal to 16.5675. Alright, so the conclusion, I mean, you cannot have a sample like this as a sample size, right? It needs to be a round number. So that means that n has to be greater than or equal to 17. Alright, so this completes question 2 of the tutorial sheet. Alright, so let's move on to question 3. Here you have the manufacturer with a mean lifetime of 1800, n is 250. This is the sample mean, and this is the sample variance, and we want to test this versus this at alpha equal to 0.05. Right. So here you are trying to test mu equal to 1800 versus mu not equal to 1800. Okay. Now we did a similar question in earlier in question 1 of this sheet. I told you that in that case we reject H0 if in that earlier question the sample standard deviation, well, the population standard deviation was none, right? But the main difference in this question is that we are not saying that the population variance or the population standard deviation is none, right? So in this case we need to use a different rejection rule, which I mentioned in the video on one sample test, which is this. I don't know if you guys remember this. Is x bar minus mu0, which is in this case is 1800, divided by s. S is the sample standard deviation, divided by n is the absolute value, has to be greater than the percentile of a t distribution with n minus 1 degree of freedom. So this is, if you look at the one sample test video, this is the rule when the population standard deviation is unknown, which is the case in question 3, right? But if you read the question here, it says that the sample size is 250, right? The sample size n is 250, which is a large sample size, especially in statistics. Anything about 25 is considered large, right? All right. So in that case, you can approximate the percentile of t with the percentile of a standard normal. So what I'm going to say is the following: since n is large, I mean is too large for a statistician, then approximate test is to reject H0 if okay. Right, that's because we can, for a large n, we can approximate the student's t distribution by a normal distribution. In fact, one of the properties I mentioned in the video on student's t is that as n approaches infinity, the student's t distribution approaches the standard normal distribution. Right. Okay, now let's see. Okay, so let's compute this guy, the left-hand side first, right? The left-hand side of this inequality is x bar. X bar is already given to us as 17946 minus 1800 divided by s. S is the square root of the sample variance, which is 2484 square root, and n is the sample size, so it's 250 square root. Alright, so if you work this out, let me check, it will be 1.713 approximately. Right, the right hand side, which is this guy here, is z. The alpha is 5%, so alpha by 2 is going to be 0.975. So that's going to be, if you read that off the table, it will be 1.96. Okay. All right. So the conclusion is that since this is not greater than this, right, we can say that there is no evidence. So since the left hand side is less than the right hand side, right, there is no evidence to reject the null hypothesis. Alright, so this completes question 3 of the tutorial sheet. Okay, so now let's move on to next question 4. Right. So here we have you have a normal distribution with this mean and standard deviation of 8.7. N is 20. Sample mean is this, and we want to test this versus this. Right? Okay, so there are two parts. The first part is to carry out the test at 5% level of significance. So this is question 4, part 1. So we are testing mu equal to 250 versus mu greater than 250. Right? In this case, we are assuming that the population standard deviation is none, which is 8.7. And if you look at the video on one sample test, in this case, we reject the null hypothesis if the following is true. That is, x bar minus mu0, which is 250, divided by sigma by root of n is greater than this. Right? Now let's put in the numbers. X bar is given to us as 252.96 minus 250 divided by sigma is 8.7, n is 20, greater than z, alpha is 5%, so this will be 0.95. Okay. So let's see. So this will be, if you work out the left hand side, right? The left hand side is approximately equal to 1.521, and the right hand side is 1.645, and this is clearly not true. Okay, so the conclusion is that there is no evidence to reject the null hypothesis, right? Okay, right. Okay, part 2 of question 4. Calculate the probability that the test will correctly reject H0 when the true mean is 255 and also when the true mean is 257. Right. Okay, let's see how we can do that. So let's first of all, let's take the true mean to be 255, all right? Okay. When the true mean is 255. Okay. Okay, so now in this case, this will be the probability that we reject H0 if this is the case, right? Okay, so now, the true mean here is 255, not 250. So what the first thing you need to do is to change this to 255. All right. So one way you can do is as follows. Right, and add. Okay. All right. Now I'm going to take this term here, 5, to the right hand side. So it will be Okay. All right. Now, this guy here, what you have is x bar minus the true population mean divided by sigma divided by square root of n. And if you look at my video on the normal distribution, one of the properties I mentioned, I think I mentioned this before also, that if if you have a random sample from this distribution, right, then the following property is true. Right? Okay, so you should see this. You should look at the video on normal distribution. You will see this. You will see this property. Alright, so I'm going to use this. So using this, we can say that this guy is a standard normal. So this is the probability that the standard normal will be greater than 1.645 minus 5 times root of 20 divided by 8.7. Okay, we don't need the conditioning anymore because we have used the conditioning to argue that this guy has a standard normal. Right? Okay, so this you can write as 1 minus the probability that and this is simply 1 minus phi. Remember, phi represents the CDF of the standard normal at 1.645 minus 5 times root of 20 divided by 8.7. Right? And if you compute this, using the table or using the R software, all right, you will get this to be equal to 0.82. Right, so this is when the true population mean is 255. Now we need to do the same thing over again when the true population mean is 257. Right, so let's continue. So the next thing we want to find is the probability of rejecting H0 when the true population mean is 257. Right? Okay. So it will be the same process one more time. So this would be the probability that the next thing I'm going to do is to make this into 257. Right, so that means you need to add a 7, right? Alright, the next thing I'm going to do is to bring this term here to the right hand side. Okay. All right. Now, by the property which I just mentioned, right? By this property, this guy here must have a standard normal, right? So so 7. Okay. Okay, now once again we don't need the conditioning anymore because we have used the conditioning to argue that this has a standard normal distribution, right? And this you can write as 1 minus the probability okay, and this is 1 minus capital Phi okay. If you read this off the table or if you read it using R, this will be approximately 0.98. Okay, so this completes question 4 on the tutorial sheet. Rise the next. The next question is question 5. So here you have we are testing for mu equal to 64 versus mu not equal to 64 at alpha is 0.05 and if the sample size is 54, the sample standard deviation is 9.2, right? And the sample mean is 66.3. Right? Now, in this case, we don't know what the population standard deviation is, right? So here you do need to use the other rule that I mentioned a while ago. That is, you're testing so in this case you will reject H0 if the rule will be x bar minus mu 0, which is 64 divided by s, the sample standard deviation, right, greater than t, the percentile of t at this with degree of freedom n minus 1. So this is the rule that we need to use here. Alright, so this will be x bar is already given to us, which is 66.3 minus 64. S is 9.2, N is 54, alpha is 5%, so this is 0.975, and N minus 1 is 53, right? Now if you compute this, you will get this to be 1.837, and if you read this from the table, right? For the t distribution, this will be 2.006, right? And clearly, this is not true, right? Okay, so the conclusion is that there is no evidence to reject the null hypothesis. Right? Okay. So that completes question 5. The next question on the sheet is question 6. Hope you can read it. So this is about this hypothesis here. We are trying to test whether the proportion is equal to 0.5 versus the alternative that p is greater than 0.5. Okay. Okay. So let's see how we can do this. Question 6, part 1. Right, if you look at my video on one sample test, you will see that for when you have hypothesis like this versus this, the test statistic is to use is the following. Well, this is the formula I gave you in the video and also in the handwritten notes, right? You can see this where x bar denotes the sample proportion. Okay, so that's the answer to the first part. The second part is asking you to use a normal approximation to find a test at 5% level of significance. Now, this statistic itself uses a normal approximation. And once again, if you look at my video on one sample test, you will see the rule for rejecting that I gave you is the following: is if excuse me. If this is greater than z or z 1 minus alpha, in this case your alpha is 5% or 0.05, right? So this is the rule. This is the answer to part 2. Part 3 is to carry out the test and report the conclusions. So, alright, now to carry out the test, we need to compute the left-hand side and the right-hand side. So the left-hand side, x bar is given to us. It's equal to 478. It's a sample proportion 478 out of 920. Okay, and this is divided by 478 divided by 920. 1 minus of that, and divided by n is 920. Now, if you compute this, right? If you compute this, you will get it to be equal to 1.1869. All right, and the right-hand side is the percentile of the normal distribution, which is 1 minus 0.05. So z 0.95. and this is 1.64645. All right. Clearly, this is not greater than this, right? So the conclusion is that there is no evidence against the null hypothesis. Okay. All right. So in other words, there is no evidence against the hypothesis that the population proportion is equal to 0.5. Okay, so that completes part 3. Part 4 is what is the probability that the procedure in 1 and 2 correctly rejects H0 when the true value of P is 0.55. Right? So let's see how we can do that. So this is part 4. We want to find the probability of rejecting H0 when the true value of P is 0.55. Okay. Now, if you go back a few steps, right? You see, this is the rule for rejecting the null hypothesis, right? So what we are looking is the probability that X bar minus all right. Okay. Now, I'm gonna tell you how to derive this. Right. Now, the true value of P is no longer 0.5. Rather, it is 0.55. Right. So what you need to do is to change 0.5 to 0.55. Right? So to do that, I'm going to do the following. Okay. Now, since I have changed it, I need to add something to make it back to 0.5. Okay. So I'm going to add 0. Right. See what we've done. Okay. And then in the next step, I'm going to take this term here to the right hand side. So this is going to be 1.645 minus 0.05 divided by okay. Now I'm going to use the result that I mentioned earlier, that this guy here can be approximated by standard normal distribution, right? Because I don't know whether you remember that in the tutorial, no, it's not on the tutorial, sorry, it's on the video on binomial distribution, right? If you looked at you should go back and look at the video on the binomial distribution, it says the following, that if, let me write it down again, if you have a sample x1 to say xn IID from a binomial distribution with say parameters m and p, right? Then x bar, you can approximate x bar, right, by as a normal distribution with parameters p and yeah, you probably remember this. If you don't remember it, I suggest you go and look back at the video on binomial distribution, right? Okay. So let me put this. Now this is an approximate, so I put a dot, right? What this implies is that x bar minus p divided by the square root of this, right, has an approximate standard normal distribution, right? So using this fact, I can say that the left-hand side, which is this one, right, has an approximate, so I should use approximate standard normal distribution greater than 1.645 Okay, now we don't need the conditioning here anymore because we have used the conditioning here to argue that this has an approximate standard normal distribution, right? Right, now this guy here, this you can write as 1 minus the probability that n of 1 is less than or equal to 1.645 minus 0.05. So there's a square root dot here. Now let me put in the numbers for x bar. As you may recall, x bar was 478 divided by 920. Okay, and this should be divided by 922. Okay. Alright, so these are the numbers. I put them back in. Now this is simply 1 minus phi at 1.645 minus Right. Okay, now if you read this off the table or if you read this using the R software, you will get this to be equal to approximately 0.92. Okay, so this is the probability of rejecting the null hypothesis when the true value is 0.55. Okay. Right, so this completes question 6, yeah. Question 6. And the final question on this sheet is question 7. Right? Hope you can read it. Let me zoom it in. All right. Here you have two parts. The first part is you're trying to test whether p equal to 0.1 versus p not equal to 0.1 with the 5% level of significance. Okay. All right. So question 7.1. Okay. Now, as I mentioned earlier, in this case, the rule for, well, if you look back in the one sample tests, the video on one sample test, you will see this. This is the rule. The rule is to reject the null hypothesis if the following is true. Right, this is the rule, right? So I'm going to compute the left-hand side and the right-hand side, and then decide, right, what to do. Right, so let's start with the left-hand side, which x bar is given to us. X bar is given to us as 47 out of 400, right? So it's 47 out of 400. That's the sample proportion, minus 0.1 divided by right? Okay, so if you work it out, you will get the following. You get 1.166667, right? So that's the left-hand side. Now the right-hand side, we want 5%, right? So alpha is 0.05. So Z1 minus 0.025 is Z 0.975, and that's going to be equal to 1.96. Right? So clearly, the left-hand side is not greater than the right-hand side. Okay. Okay, so once again, the conclusion is that there is no evidence against the null hypothesis H0. Okay. Alright, so that completes the first part. The second part of the question is to calculate the approximate probability of correctly rejecting H0 when P is 0.103 and also when P is 0.105. Okay, so let's see how we can do it. So this is question 7, part 2. So let's start with this value of P first. Okay, then we'll do this later on. So you want to find the probability of rejecting H0 when P is 0.103. All right. Now this, if you go back to the earlier part 1. This is the rule for rejecting the null hypothesis. Okay. So that's what I'm going to write down first, right? So And this is x bar minus 0.1 greater than 1.96 given with the true value is 0.103. Okay. Right, now just like in the previous question, what you need to do first, because the true value is this, you need to change 0.1 to this, right? So that's what I'm going to do first. Right, because we have added this term, right? We need to get back to this. So to get back to 0.1, we need to add 0.003. Okay. Alright guys, now what I'm going to do is I'm going to take, alright, in this case we have an additional problem because of the absolute sign. So the first thing you must do is to get rid of the absolute sign, right? So it's not easy, you can't take this directly to the right hand side without first dealing with the absolute sign. So let's first deal with the absolute sign. So this will be without the absolute sign is either greater than 1.96, right, or less than minus of 1.96, right? So given p is equal to 0.103. All right. So you see what I've used here. I don't know whether you know this, but if you have something like say z greater than a, yeah, this is the same as saying that z is greater than a or z is less than minus a. That's what I have used. That's what I have used in this step from this to this, right? I have used this. You should know this from your math courses, right? Anyway, all right. Then, because these two are mutually exclusive events, you can separate them out, right? So you can write them as. So I want to separate them out and also take the third term within each to the right hand side, okay? So this is what you will get. This is the first probability, and plus the probability corresponding to this, which is Okay, now because of the argument that I made in the previous question, question 6, these two guys here must have an approximate standard normal distribution. So this and this. So that's what I'm going to use in the next step. In the next step, I'm going to argue that because of what I mentioned in the previous question, this probability is approximately equal to okay, and we don't need the conditioning anymore because we have used the conditioning to argue that this has an approximate standard normal distribution, right? Okay. All right. Okay. Now, the next step. In the next step, I'm gonna write this guy here. The first as 1 minus the probability that NO1 is less than or equal to 1.96 minus okay, and plus this term here, the probability that this is less than okay. Alright guys, now in the final step, or at least the penultimate step, you can write this as phi at 1.96 minus 0.003 divided by our x bar. X bar we know is 47 by 400. Okay, and 1 minus x bar divided by n, which is 400. And this term here similarly minus 1.96 minus 0.003 okay. Now you should compute these two probabilities using the table or using the R software. Either way you will get an answer close to this. Okay, 0.058. So that is the probability of rejecting the null hypothesis when P is 0.1 or 3. Yeah. Okay, now we need to repeat the whole thing when P is the other value, which is 0.105. Okay. So let's repeat it. So this is still question 7. Part 2. So we are looking for the probability of rejecting H0 when, in this case, P is 0.105. Okay. So this will be, as I said before, you have the probability of rejecting is x bar minus 0.1 divided by this, right? Greater than 1.96. Alright, the first thing to do is to change this to 0.105, okay? Alright, so now we need to add something, which is going to be 0.05. Alright, the next thing is I'm going to get rid of the absolute sign, and for that I used the rule that I mentioned earlier, which is this rule here, right? Okay, so this is what you will get. Okay, now these two events are mutually exclusive, so their probability is the sum of the probabilities, right? So this would be right. I'm going to take the third term here, which is this one, to the right hand side, so it will be 1.96 minus and plus the probability that this is 0.005 divided by Right. Now, in the next step, I'm going to use the fact that this and this has an approximate standard normal distribution given these two. That's a property I mentioned in the previous question, question 6, right? So you can write this as the probability that NO1 is greater than 1.96 minus we don't need the conditioning anymore, right? Plus the probability that NO1 okay. All right, and in the next step, I'm gonna write the first probability as 1 minus. So this you can write as right, and okay. And in the penultimate step, I'm going to use the fact that phi, which denotes the CDF of a standard normal, 1.96 minus 0.005 square root. X bar, is the same as before. It's 47 divided by 400. And plus okay. Now, you should compute this using the table or using the software, our software. You will get this to be 0.068. Right. So this is the probability of projecting null hypothesis when p equal to 0.105. All right. So this completes the question 7. And also completes the video solution to tutorial sheet 11.